Would you like to upgrade the framework or database, but it seems impossible due to high coupling? And maybe you think about rewriting the project from scratch again? In front of you is Damian Dziaduch, a professional programmer since 2011, all the time in PHP. He will convince us that framework-agnostic is not a rocket science. Let's listen to Damian and his talk.
Before we start, I want to ask a question. Is there anybody in the room who speaks only English? Yes. Okay, so we will do in English. Okay. Okay, we'll do in English. I just want to confirm. Okay, so good afternoon, everybody. I hope you are not tired yet because there is a lot of stuff going on today. And thank you for joining me in this talk. And in this talk, as it was said before, I want to convince you that framework-agnostic approach is not a rocket science. And in order to do so, I would like to present you our approach to this subject. So this talk will be based on experiences from the company which I'm working currently in, and this is Printify. So let's begin. I will start with presenting myself a bit because maybe you're not familiar with who I am. I started my, let's say, career as a public speaker this year, and here we are. I'm also, of course, a software engineer. I'm working at the Printify, and the Printify is a company with the mission. Our mission is to change the world. We want to transform the world from mass production into on-demand production. And before that, I was also working in two companies, local ones, which were also a product company. So I have a background with the product companies. And I'm also a fan of TDD and architecture, and both topics will be covered in this presentation. So let's take a look what will be in this presentation. So let's take a look at the agenda. So first I want to answer the question, what is framework-agnostic approach? Then I want to show you why you should care, why you should do this. Finally, maybe not finally, but on the third, I want to name the benefits that this approach will give you. And finally, I want to show you in details how we are doing. And there will be, maybe not live coding, but I will show you some code. So start with the definition. So what is framework agnostic? So the definition from the internet is like this. It's a framework agnostic approach refers to developing software in a way that minimizes dependencies on specific framework. Quite long, but I think we can do a bit more simple. It's just separation. We separate the framework from our application code. We have an abstraction over our application, so the framework is separated. Okay, so now you may be thinking, okay, why should I care? Why should I do it? So my answer will be, I will show you some code. I hope it will be visible. And as you can see, this is typical HTTP controller. So we have a lot of stuff going on here. For example, this is a controller. We have some entities. So we have some DB connection here, some HTTP handling, JSON responses, some domain logic here is. So everything is mixed here. And as you may guess, maintaining such code is not a pleasant experience, of course. Everything is tightly coupled. So now I have a question to you. What do you think? How hard would be test such class? I imagine like setup method would be like super long because you have to like start kernel of the framework, you have to stop the HTTP response, you have to put some stuff into database. So a lot of stuff needs to be done in order to test this. And also it contains a lot of edge cases. So there has to be like a lot of data providers maybe, so the test will be quite heavy and quite long, and it will take a lot of time, of course, to execute and to run. So we wanna not do it. Okay, so now let's maybe name those things, what this approach exactly gives you. So somebody might change, okay, I can change the framework. Framework is separated, but in reality, who changes framework like, maybe I will ask you, who changed the framework like from, for example, from Laravel to Symfony or something else? Oh, there is somebody. Interesting, okay. But as you can see, this is a very rare case. So we should not focus on this. Of course, yes, so let's name those benefits. So the benefits are like, first, I think it's separations of concerns. So this approach will give you the order in your code. Something which, similar which Michał showed in his presentation about DDD, we will have places like directories where we can put everything in the code. You will know where to put the stuff. Besides that, I mentioned the tests. So the test will be much faster and they will be much, I think, easier to write. So easy to write and also fast by execution time. The last thing which I want to mention here is code reusability. We use services or use cases, and it's super fine because we can reuse them. For example, we had a case where we first started a service, we implemented a HTTP method, but then we figured out that, hey, we want to do the same thing on some event, and we want to do this via CLI command. So by this approach, we were able to do it very, very fast. Okay, so now, this is the last part of my presentation, but it's the longest, because now I want to show you how we are doing it. So, but before I jump to code, I want to first talk, of course, about the domain. So in this sample application that I want to show, there is a driver's penalty point system in Poland. I think many of you might be familiar because I think a lot of people drive by car here or they have driving license, they are familiar. So what are the rules of that system, of this domain? So for the fresh driver, let's say, for junior driver, let's call him like this, junior driver, he is allowed to have 20 penalty points limit because he passed the exam less than 1 year ago. And for the senior drivers, there is a limit, 24 points. So up to 24 points, you can still drive. If you reach it, you cannot drive it anymore. Okay, so speaking of the penalty itself, the penalty itself is valid 2 years. 2 years. And this period is counted from the day of the payment. So when the driver pays the payment, and when the driver can pay for the penalty. So the driver had two options: either he can pay on the spot, I take it to the police officer, here is my card or cash, take it. Or he can decide, okay, just give me the bank account number and I will pay later. So, and he forgot about it, of course, and then he pays like half of a year later, and then the penalty is finally like 2.5 years valid. And the last rule in this system is imagined by me. So if you reach the limit, you instantly go to the jail. So this is the rule which is in the system, which is not a real rule, of course. So let's quickly discuss the users of our system. Of course, we have a police officer who can do one thing. He can impose a penalty on the driver. And besides the police officer, we have the driver, of course. And the driver can pay for the penalty, one action. Okay, and now I want to mention the architecture which we are using. This is ports and adapter architecture. So, and the question I have, I have no question for right now. Who knows or uses ports and adapters or hexagonal architecture? Yeah, nice, nice, good one. Okay, so the definition of it is it aims at creating loosely coupled application components that can be easily connected to the software environment by means of ports and adapters. So we have ports and adapter, but what does it mean? We can simplify this, of course. It's a separation of the framework of the tooling by means of those ports and adapters. So the ports and adapter are the tool which allows our application to be separated from the framework. And I have also a small disclaimer here. We think that this is not the only approach to framework agnostic. This is just our approach. Okay, so before we jump into the code, I wanna do a view, like a helicopter view of this project. So what I will do now is step by step show you how we will implement the code in this system. So where do we start? So will be similar to Michał's presentation about DDD. We do not start with HTTP payloads or with DB schemas. No, we are not interested in that. We are interested in our domain, so in those rules, in those penalties, how they are valid in those points. This is the thing which we have to implement as the first. So we do it as a first, and we will have classes like representation of the penalty, for example, and we will have a representation of the driver, and we will call it the driver file. So this will be an aggregate which contains all the penalties of the driver. And we first defined it. So what we have to do later? We define application on top of our domain. So what is application? Application is something which orchestrates, which uses our domain. And as you can see on this picture, we have those things here. Those are called get driver file and store driver file. So this might be similar to you to the repository pattern from the DDD book, but we divide the repositories into more granular interfaces because we follow SIP rule from the solid. ISP, sorry, interface segregation principle. And this allows us to connect with the storage. So our application now consists of the domain, of course, domain is inside, it's the core, and we have the application. So what is this application? We have the service. We have two services because our application now is able to do two things. We can first impose the penalty on the driver, and second thing, the driver can pay for its penalty. So we have two services which allows the users to do so. And of course, we need storage. So we define storage with these interfaces. So what are those interfaces? Those interfaces are in the application, and they are owned by the application. But the application itself on this stage does not care how the persistence is done, how those things are stored. We don't care about that fact now. So we only need those interfaces. We can quite easily test our application now by just stubbing those interfaces, for example, or providing some in-memory representation. So this is application. And now let's jump forward. Now something changed. So as you can see, besides our application, outside of our application, we have something new. We have adapters. So there is in-memory adapter, mock adapter. So what are these? So those are the concrete implementation. Concrete implementation, in this case, of the storage. So for the storage, we have two implementation. One, we have in-memory implementation and mock implementation of the storage. So why this is outside of our application, you might be asking? Because we want to have this abstraction over our application. We don't want to have coupling between storage and our application. And by these ports, we are able to do so. Because those interfaces are called ports in our application. So we define in our application that, hey, we want to have storage, but we don't care how it's working under the hood. And the implementation lives outside of our application. And now you might be wondering, okay, so how I connect it? So I do it via dependency injection container, of course, because we don't want to have direct coupling. We want to wire things on the dependency injection. And by doing on the dependency injection level, I can switch the implementation of the storage, maybe not on the fly, but I can very easily switch it because it implements this interface. So if I would add here another implementation like MySQL, for example, I can very easily change that. Just change in the DI, and voila, we are done. Okay, so now we have the application, which is able to store something in the storage. We have the domain. So what's next? What next? We would like to have our application to be used by somebody, because currently we have just a service. There is no like HTTP controller or CLI command or whatever. So how to do it? So what we do, we define another pair of ports, but they are on the different side. Why they are on the different side? Because the traffic comes from the left side to the right. So those ports define the capabilities of our application. Now, right now, this application is simple. It has two capabilities. It has a capability we can impose the penalty on the driver, and we can also pay for the penalty for the driver. Okay, so we define the port, but where are those controllers, let's say, or those CLI commands? Well, they are also not in the application. They are, of course, outside of the application. So the application itself owns this contract, this port, and it says, okay, via this port, you can, in this application, do something. But where is the implementation of this port, you might be asking? So the implementation of this port is in the application. It's implemented by the service, because service can do so. So our service implements the interface, this port. So we have a service which allows, for example, to impose the penalty, and there is a contract for that. There is a port for that. Okay, so now we have interfaces, we have services which use those which implements those interfaces. So who is the user of this interface? Who is using it? Of course, it's adapters. So for example, let's imagine this adapter, this HTTP adapter, which allows the driver to pay for the penalty. So how it's done? This adapter will have injected DI this. It has dependency to this port, to this pay penalty, but on the DI level, it's wired to the service. So the adapter does not have direct coupling to the service, because the adapter does not care how the application logic works, how the paying is done, or how the imposing is done. So this is from the big perspective. So now what I want to show you is, of course, the code. Okay, you don't see it. Hold on. Let me just quickly change it. Maybe this way. Okay. Hold on. I wanted to switch to mirroring settings, but how to do it? Not sure. Okay, never mind. Let's do it like as it is. Right now, where is the cursor? Okay. So how we wanna go? How we are going to do it? Oh, why it's not working? Oh, there is. So I created this code, and there is 4 branches. I want to go with you step by step into those branches, so they represent the steps which I shown you on this diagram. So let's start, of course, with the domain, because this is what we wanted. And I have a question. Is the font readable for you? This is presentation mode, so I think it should be. Okay. So let's take a look at the folder structures maybe first. So as you can see, we have only in the source code, we have only domain. We don't have anything else. We don't have controls. We don't have storage. We don't care about it in the domain. So first, we distill our domain. So as you can see, we have the class which represents the penalty. So this is the penalty which can be imposed on the driver. As you can see, we have like some identification numbers and some other data of it. And of course, as I said, we can create unpaid penalty. And of course, sorry, it's hard to do it like this. And we have paid on the spot. So there are some other rules, like we can pay the penalty, but the penalty can be already paid. We can check whether penalty is valid and whether it's paid. So this is simple class that represents the penalty. There is nothing sophisticated. It's pure PHP object. And besides that, we also have the aggregate. The aggregate, which is a driver file. And the driver file, of course, consists of penalties. So every penalty which is imposed on the driver goes to his file. And of course, it's done via behavior. We have the behavior here. So we can impose the penalty, of course. There is some exception which can be thrown when the driving license is not valid anymore. We can either pay for the penalty. We can ask whether his driving license is valid at this moment. We can ask what is the valid penalty points sum for him. Or other stuff like maximum number, like whether it's like junior, senior. You remember there was this rule like 20 points, 24 points. So this is the domain. But we don't want to focus on this too much. There was like this very good Michał's talk about the DD. So now what we want to do is go further. We define our domain. So now it's time to do some orchestration. So we need application. So what changes now? As you can see, we now have domain plus application, and we have something called adapters. Okay, so the domain is unchanged. It's the same as it was before. So what is in the application? Let's take a look. First, we have those ports. Those are ports for the storage. We have the one port which allows us to get the driver file from the storage. And it's super simple. It's defined, hey, if you provide me this license number, I will give you this driver file, or I will throw the exception, hey, that does not exist. Super simple. Besides, we have also a port for storing. It takes driver file and returns nothing. Super simple. And now let's take a look who is using it. Okay, so we have the services. So let's take a look at the first service. So the service has those ports injected in the constructor because we inject them on the dependency injection level. And this service allows us to do one thing, impose the penalty on the driver. Of course, it's using this domain object, but first it has to retrieve it from the storage. And finally, when it's done with changing this driver file, so the penalty was imposed, then it's storing it. So this is the service. Now let's maybe take a look at the test of it. So this is the test for the service. As you can see, it's a unit test case. It's a simple test. So we test that it imposes the penalty and then stores it in the storage. So for sake of this test, I created a simple implementation of the storage. In memory, it's very, very simple. It has this array which contains all the driver files, and it implements both ports. And what is interesting about this in-memory driver files, it lives outside of our application. Because as I said before, we don't want to have anything related to store it in our application. So it lives in the adapters directory. So we have domain, application and adapters. And the ports are owned by the application and they are in the application. So let's go back to the test. So we create the service, of course. We inject the dependencies. We impose the penalties, 3 penalties here, and we expect that it will throw some exception, but because this is our contract. And finally, we check that the driving license is not valid anymore because this exception was thrown, and we check how many points the driver has. Of course, we can test also the edge case. The driver file does not exist, so we expect this exception to be happened. Super easy test and super easy to write. Okay, so we covered the services and the ports for the storage. So now it's time to wire our application and allow it to be used by the user. So now we will jump to another branch, and this will be this one, adapters. Okay, config, we don't want a config. So let's take a look at the SRC. So what has changed from the previous branch now? Let's take a look at our ports. So in the ports, now we have 2 directories. Those are the same that were before. And now we have new ports here. So those are the ports that define the capabilities of our application. And let's take a look where they are used. They are implemented, of course, in the service, as I said you before. So the service is responsible for doing it, but it implements the service. So we have an abstraction over our application. So now for example, HTTP controllers will not be directly coupled to our application. They will use the application through this port. So let's take a look at this port again. And let's take a look, for example, at, I don't know, CLI command, let's say. So there is where is this cursor? Okay, so we have the CLI adapter here. I call it CLI adapter, but you can call it CLI command. So what it does, as you can see in the constructor, we have the dependency to the port. We don't have dependency directly to the service. Why is that? Because it allows us to easily test this CLI command, because we can, of course, mock this port. We don't have to run whole application, because in reality, what does this CLI adapter? CLI command takes the input from the user, converts it to the input understood by our application, and passes to the application. And the application responds with something, and then again this CLI command converts this thing returned by the application to the something understood by the user. So let's take a look. Maybe let's close this one. So how it does? It's when it's executing. It takes input from the user, of course. It does some basic validation of the types, because the types are required here for the application. And here is the thing. It uses this port to execute something on the application. So this is our contract for our application. And the contract say, hey, if you do this, something unexpected can happen. You can do something about it. So yes, we can do something about it. Why not? We want to inform our user, hey, something unexpected happened. Here is the message. And we return the failure, of course. But in the case of success, we say, hey, the penalty was imposed, and it's success. Okay, so let's take a look at the test, because I told you there will be some tests. Here is the test. So now the test, as you can see, is not a unit test. And why is not a unit test now? Because this is the part. This is not the part of our application. This is the part outside of our application. So this is the part that can be tightly connected to the framework, to the tooling. And this application which I'm showing you is using Symfony. You see, we didn't mention Symfony till now. So this is a very good example how this framework agnostic works. So this is a Symfony. So of course Symfony gives you a tool to test CLI commands. There is something called command tester. So we can boot our whole application. It allows us to stop our, or mock in this case, mock our contract from our application. So we expect that it will call our application, this method, with those arguments. So we set this expectation in the dependency injection container, and we run the command. So this is true responsibility of the CLI command or the HTTP adapter. What it does, it adapts the input, incoming input, into the input understood by application, and then handles the output from the application and translates it, for example, to the HTTP response, for example. Oh, that's a good example. Let's maybe take a look now at the HTTP controller. HTTP, let's stick with this imposing penalty. So there is imposing, what time do we have? I think we have imposing penalty. So again, we have only one dependency injected here. This is the contract for our application. Those things are of course passed by the routing, because this is Symfony. So Symfony passes from the routing from the URL parameters, and it's expected to return the response. So we execute our application here. We pass the params. Of course, we can catch the things from the contract if something unexpected happened, and then we return to the user, hey, by the request, something wrong happened. And in case of success, we return no content. Now I want to show you how it's wired on the DI level. We use PHP configs, and this is our preference. So let's take a look maybe at this HTTP controller. So here we have it. We have a HTTP controller, we call it adapter, because what it does, it's adapting this input from the user to the input by the application. We tag it, and we pass the service, of course, by this port, and this port is defined here. So it says, if you want to have this port, you will receive this service, and this service requires also those ports, and those ports are defined here in memory. Okay, and last thing I want to mention, because you see a name here in the ports, primary and secondary. Some of, there is like two standards, I would say. There is like saying primary or secondary or input output. So what is primary and secondary? The difference. So for the ports, so the primary ports are the ports that are driving our application. So the user is using it to do something on our application. So this is similarity to the primary actor in the movie. So he is doing the action. So he is responsible for it. So then what is the secondary? Secondary is a port which is driven by the application. So the application says, hey, do something for me, store it in the storage. So it's similar to the movies. It can be like secondary actor. So he's doing something for somebody. Okay, of course, this code is available on my GitHub if you want to take like a maybe more deep dive look. So now let's get back to the presentation. What time is it? Okay. Okay, we code we have. So now it's time to wrap it up, everything, sum it up. So First, we answer the question, what is the framework agnostic? And framework agnostic is just a separation of our application from the framework, from the tooling. It gives us this separation of concerns. So we have a domain, we have application code, and also we have the adapters where everything is wired to the tooling, to the framework. Tests, they are easy to write. We don't have like this huge setup methods. They are easy to do and they are fast. And of course, this services or cases reusability. Oh, I forgot to show you. There is like a one service is used in the CLI. Oh, I showed you. There was like this HB controller and the CLI. They use both the same port and the same service. And finally, we are doing it, of course, via ports and adapter architecture. And here's more small shameless plugs. We are hiring in Printify. If you want to join us, do the hexagonal architecture, come and join us. And that's all from me. Sorry for being late to this presentation. If you wanna, there is a GitHub. There is this source code which I shown you. You can take a deep dive. You can find me on the internet via this handle. I'm recently most active on LinkedIn. There is also my blog where I write something, and the presentation will be, of course, available on SpeakerDeck. And last thing, before you leave, I want to ask you for the feedback. I think it's on this Join D portal or something like that. You can leave the feedback there. And do we have time for questions? Yes, any questions maybe? Okay. Or there is no questions? Yeah.
Okay.
Speak loudly.
I was wondering, because the secondary adapter was storing the driver file,
Yes.
if I remember correctly, which was wrapped in finally after try. So why would you want to store the driver even if there was exception?
Because that was a rule from the use case, from this business. Like there was a rule when the last payment is last penalty is imposed on the driver. He reaches his like point limit, then he needs to be taken to the jail. That's why the exception is thrown, so that could be catched, and the police officers can do something about it.
Okay. Okay. And second question, if I may.
Yes.
How do you see the ports and adapters comparing to command bus approach? Because everything that was done here with ports and adapters could be easily achieved with command bus, because you could dispatch command in the CLI command or HTTP controller and do exactly the same, but in the handler, and the handler could be tested just like the services. Yes,
of course, you can do this. We are recently started doing this approach with command bus. So the interface to the command bus, of course, is our port, a primary port to our application, and you can execute on it the commands, of course, which are like this inputs to our application. So yeah, that's a good point. Any more questions?
Okay, so my question is according to this first question.
Yes.
There was indeed the exceptions, and I see, for example, in the comment, I mean the CLI comment, you have used the try and catch. Now we all know that using this for, let's say, stirring of the exception is actually bad pattern. But in that case, I think it was quite okay. So my question for you is where you see that the limit, the way, the point that you can or cannot use the exceptions, in fact, to stir the logic and catch.
So you ask, like, what is the limit when like using the exceptions, where we should not use it? Okay, those exceptions were mostly from the domain, so they were clearly like from the business rules. But I wouldn't think that you should, for example, use it for like logic. there should be like, you can use like booleans or if statement, whatever works for you. Okay, any more questions? No? Okay, so then thank you very much and thank you for joining me in this talk.